Hi, my name's Antonio, and I'm going to be showing you guys how to solve the first problem on Project 2 of ENGI 1331 with Coda, Tuesday, Thursday, 2:30 to 4. So this first problem, what it's asking is for us to solve a system of equations in and put it in upper triangular form. Now, what is upper triangular form? This essentially right here is upper triangular form. We have a matrix that is 3 by 4. Now, it doesn't have to be 3 by 4, but for the sake of this example, it's a 3 by 4 matrix. The important part to remember is that the number of columns is one more than the number of rows. So, let's jump into it. First things first, of course, let's title our work. I'm just going to name it Project 2, number 1. Let's get some housekeeping commands. Okay, and let's get started. First, of course, we enter a set of data. We say input, enter a matrix of size n by n plus 1. Oops. Okay, we have our data that can be set. Now we're going to get the dimensions of it. We're going to get our row, our column, and we're going to send data to the size function. Now what we want to do is we want to make sure that, again, it is in the right dimensions. A 3 by 4, 4 by 5, a 5 by 6, anything where the number of columns is one more than the number of rows. So let's form a while loop that says while the number of columns is not equal to the number of rows plus 1, initiate the while loop. We're going to output a warning. That is going to say, let's just say wrong dimensions. Output that warning. And we will simply ask for a new matrix, take the size of that, and then we'll initiate the while loop again. So I just copied and pasted that. Let's format that correctly. And we can end our loop. Now let's run it, see what we get. We have a, let's do a 2 by 2. 2 by 2, wrong dimensions, of course. So we enter, let's do a 3 by 3, wrong dimensions again. Now let's enter our correct matrix, 3 by 4. And there we go. We can see that it accepted our matrix, which is a 3 by 4. So once that checks out, we are ready to send it to our function, which I will create now. Of course, we titled it function. We give ourselves an output. Give me 1 second. Okay, we're going to name this our upper triangular form. I'm just going to say upper. We're going to name this uptry. And it's going to accept a number of rows, number of columns, and and our data matrix. Alright, now, initially what we want is a matrix that has a value in the first cell right here, the first column of the first row. Reason for that being, that is our x value per se, our x1. This being our x1, x2, x3, and the solution to the equation. I'll take the time to show you pretty much what it's saying. So let's say we have, in this case right here, we have 1, 1, 1, 1, which is saying 1x plus 1, and I'm just going to call it y. It's essentially, this is your x1, x2, x3, and your answer. But for simplicity's sake and, just better differentiation, I'm going to name these x, y, and z. And they are going to equal 1. It really is just plugging in these coefficients. What this program is going to do is essentially, since these are 0, we know that z times this coefficient equals this number. So I'll go a little more into detail as the code goes on, but that's what the numbers in these matrices are representing. So, like I said, we want our first row of our first column to be a number. We want it to have value and not be 0. So we're going to say if data of 1, 1 is equal to 0, then we set some conditions. We're going to name our first row G, and we're going to set it equal to a different matrix, any other matrix. Here I am setting it equal to a different matrix. Oops, got a comma here. Now we replace that matrix, or that vector, that specific row that it's changing with. We're going to replace it with the value that it replaced. Alright, so there we replace the matrix, or not the matrix, I keep messing up. There we replace the row. Now, we want this first number to be a 1. And that's just going to further simplify our code. That's going to further simplify our code and just make things easier for us. So, else if your data of 1, 1 does not equal 1, then you're going to make it equal to 1. You're going to divide it. You're going to divide that first row by the value of that first element, that first cell. So what we're going to do is data 1, comma, all columns is going to be equal to going to be equal to your data of first row, all columns. They're all going to be divided by your data value of 1, 1. And we can end this. So now we got it in the form that we want. So what's next is to turn everything under that first diagonal to 0. The way we're going to do that is we're going to create this counter. We're going to create a for loop that goes from x, or that goes to from 1 to column, or actually call, which is my column value, -2. Why -2? Because it doesn't go all the way to the end of the row vector. Here we have, we're gonna up our counter by 1, and we're gonna have this for loop for the rows. And it's going to go backwards. This one is going to go from the lower end of the matrix to up. Now, what we want is for our number to be subtracted by itself, essentially. The number that we are trying to get rid of. So, since we're down in our last row, we're going to say if y, which is our rows, if our y is greater than or equal to 3, and our data above it is equal to 0, and our data above that one is 0, so pretty much this guy. Sorry, I'm kind of lazy and just like to copy and paste. But so let's say that doesn't equal 0. We are going to work with that number. We're going to say our data, the row that we're looking at, is equal to data, the row we're looking at, minus the row that's not 0, in this case being 2 above the row that we're looking at. Times data of the row that we're, or the cell that we're looking at, divided by